All right, folks, welcome back. We're going to look at one KCL example in this format. It feels silly to me, but it shows up on the FE exam and in some other places. So I want you to see it once so that if you get on an exam like that, you're not taken by surprise. They take a node and they just make it float in space. Like here's a node and there's magic currents floating in and out of it. There's nothing connected to it. But you need to use KCL. So in honor of that, I went ahead and I got kind of a spacey background for you. Okay, so this is a node floating in space. Woo! I don't think it's practical, but it's practical in the sense that you might run into it in an exam. So let's go look at that and get rid of this cheesiness, including the stars in my beard. There we go. Okay, so here's your node floating in space. And there's some currents. I drew some currents going in and out of it. We'll do this one, and then I'll use it to solve for an unknown current, really. But we can say, okay, there's 4 things connected to this node in the center, and we need to make sure that KCL holds. Okay, so the current's flowing in. Let's just start here and work our way around. Let's start with the 2 amp. It's going in. In my mind, that's a plus. 2 amps. Okay, the 4 amps is leaving. Minus 4. 6 amps is leaving. 6 amps. And the 8 amps is going in. Okay, and that should all be equal to 0. That's how I would write the KCL for that free-floating space node. Okay, so 2 minus 4 minus 6 plus 8 does in fact equal 0. All right. The way it'll probably be posed on those exams, and since we're going to use KCLs to do circuit analysis, there's going to be some unknowns. So we can go crazy with this. Let's have 5 in there. It looks like a starfish or a bad stick figure, something. Okay, and let's pick some directions and some numbers. This is usually where I would ask you to dream up some random numbers. I don't have my dice with me. Sometimes I do it with dice in class. Okay, in or out, 3 amps. And since I'm making this up, I don't know what the answer is going to be. And that's half the fun. For somebody, not us, but for somebody it's going to be fun. Okay. And let's make that 8 amps. And the question is, well, what's going on with this? Now, all of the current going in has to come out. And because of that, we've got to pick a direction. It almost doesn't matter which direction you pick. And let's assume out. Here, I'll mark this up with a different color. Okay, so let's assume it's going out. And let's just call it I. Okay, if I want to find I, I'll come over here to the left, and I'll do the same thing that I did here. 3 amps is going in. 3 amps. 4 amps is going out. So it's minus 4. The I is going out. So it's minus 8 amps and minus 7 amps. And that's all equal to 0. Okay. One equation, one unknown. Go ahead and solve it, and you know the unknown. Okay, so I is going to come over to the other side, and we've got minus 4, minus 8 is negative 12, minus another 7 is negative 19, plus 3 is negative 16 amps. And that's equal to I. Okay, so we assumed a direction. I just said, it's going out. And when we solved using the math, we found that it is in fact negative. So the current's actually entering, but if I'm going to label it this direction, I have to give it a magnitude and a sign of negative 16. I'm really defining the coordinate system here. Okay, what's the current going in that direction? The current going in that direction is minus. So you got to make sure that the arrows and the polarities when you're dealing with voltages on your schematic line up with what your values are. Okay, but if you just trust the math, pick a direction, go with it, trust the math, the sign's going to fall out and it's going to be correct, hopefully. All right, so I wanted you to see it this way. I'm going to get some bigger circuits for you to play with and write some KCLs like we would as we do more advanced analysis methods. But you may run into this one, and here it is. Okay, so stay tuned and good luck.